Hello everyone, this is Haddad here again. In this lecture, I'm going to explain to you about the cost on OSPF, also referred as metric. Then that's really needed for the load balancing on OSPF when we want to do the configuration. So let's have a look now and see what is the cost in OSPF. As you can see here in front of you, we have area 0, the backbone area, and we have those routers connected to each other. So we have router 1 connected to router 2, connected to router 3, router 4, and then router 2 and router 3 and router 4 that are connected to router 5, and router 5 has a network 3.3.3.0. Okay, as you can see here, router 1 can reach the network of router 5 via 3 ways. So he can go either from router 2 or from router 3 or from router 4. Okay, all the ways to reach to this network, and that's when we enable OSPF on all the routers. Router 1 over here, he has to choose one of the paths over here, because as you can see, the cost on the paths here are not similar. Okay, just to mention something, that in OSPF you cannot have unequal cost load balancing. Okay, for example, from router 1 to go to this network over here, if you want to go, let's say, from router 2, it needs 5 plus 5, that's 10, plus 5, then it needs 15 to reach to this network. Okay, so I'll put here router 1 to go to via router 2, he needs a total cost of 15. While if he wants to go from router 3, then he needs 10 plus 5, that's 25. So from router 1 to reach the network via router 3, he needs 25 as total cost. And from router 4, he needs 20 plus 20, that's 40, plus 5, that's 45. So we have 15 from router 2, and we have from router 3 he needs 25 as total cost, and from router 4 he needs 45. These costs over here are not similar. You can see that's 15, that's 25, and that's 45. Even though that all the routes are now listed inside the link state database of router 1, but router 1 will only choose this one, and he put it in his routing table. Let's say if you want to buy a car, okay, and the cost of the car, you can find it from one agency, is less than the cost or the price from another agency, while both cars are the same, then you will go for the agency which has the lowest price and you buy it from there. And that's the same in OSPF. Router 1 will look for the lowest cost to reach the destination network that he wants to go, and then he will add it in his routing table. Now, in this case, we will have this route, which is the route that router 1 will take, and those routes here, he will not use them. He will not put them in the routing table, but they will always stay in his link state database or inside his topology database. Once this route is broken, then he redo the SPF algorithm again, and then he can put one of the routes which has the lowest cost, and then he put it in the routing table to be able to send the traffic through it. So what is the cost on OSPF? The cost on OSPF is very easy. It's based on the bandwidth on the link. That's in theory, okay? Then the cost will be, if we want to write it here, cost equal the reference bandwidth over the interface bandwidth. Okay, now the interface bandwidth, that's something we can know ourselves, because it is on the interface. We can see what is the bandwidth on the interface, or what is the speed on the interface, and then we know what this value is. The reference bandwidth is 10 to the power 8 bit per second. Okay, so 10 to the power 8, that means 100 megabit per second. Okay, so the reference bandwidth is always 100 megabit per second. That's the theory of OSPF. Okay, over the interface bandwidth. So for example, if you have the interface bandwidth of 10 megabits, okay, let's say Ethernet interface has 10 megabit, then the cost will be 100 megabit per second, that's the reference bandwidth, over 10, then in this case it is 10. So imagine we have here 10 megabit on this link, okay, 10 megabits on both interfaces over here, then the cost will be 100 over 10, that will be 10. Okay, and if you want, I can refer you here to Wikipedia. they're talking about the open shortest path first. And if we go here to routing metrics, that's what is important here. You can see here the reference value is 10 to the power 8 by default. They say if the link has 100 megabits, then the cost will be 1. Why? Because 100 over 100, then the cost will be 1. Okay. Now, in our case with MikroTik, we can play with the cost without going through all this. Okay. So there is an option inside the OSPF that we are going to see now that we can change ourselves the cost on the MikroTik router without even going through all this. By default, the cost on the MikroTik routers when you enable an OSPF is 10. That's by default inside the interface, okay? And that's something we're going to check when we do the lab, okay? So by default, MikroTik router, when you enable, for example, OSPF in this link here, on this router, we enable OSPF here also, here and here and here. Then the cost will be, you will see it inside the interface here, 10, and inside here the interface is 10, and here is 10, 10. All the interfaces here will have 10 as the cost. In our case, if we really need to use the route from router 1 via router 2 to router 5, so we need to use this route over here to reach to this network, and we want also to use the one which is via router 3, because at this moment, as it is set now based on the cost we have on the graph, router 1 will always take the first route. Okay, let me just put them. This is the second and this is the first. Okay, he always refer to the first because it has the lowest cost. So in our case, if we are using MikroTik routers and we need that router 1 send the traffic from the pass through router 2 and router 5 and from the pass through router 3 and router 5, in this case what we can do, we can make the costs similar, because again we said that OSPF use equal cost. Okay, so when you want to do the load balancing, it should be equal cost. When you have equal cost, for example, we said from router 1 to the network via router 2, you have 555, you have 15 as the cost. And from the link 2, you have 25. Okay, so this cost is lower than it would go directly from this way. But if you want to use both of them, then you need to lower the total cost over here. So this one should be also 15. In this case, when you change the cost inside the interfaces to make it 15 on both, then you will see inside the routing table of router 1 that he will put to reach the network 3.3.3.0, that's the network, you can go via router 2 and you can go via router 3. He will not put via router 4 because the cost in this case is higher, then he will not choose router 4. Okay, so all you need to do, you need to change the cost to be similar, and that's why we say for OSPF it works as an equal cost load balancing. Okay. Another thing to mention about OSPF, it works as per connection and not per packets. What is the difference between the per connection and the per packet? The difference is that in per packet, router 1 will send the packets as a round robin. For example, he will send first from this link one packet and then a second packet from this link to the network. Okay, they are all going to 3.3.3.0. Then here we go from router 2, then from router 3, then from router 2, then from router 3. That's how per packet works. But OSPF is not per packet, it's per connection. That means that the first connection which is opened and the first route is taken, then it will always go from this route, okay, until the connection is finished. And in this case, we cannot guarantee that all the traffic will be making load balancing. Okay, it may happen that it will not do the load balancing correctly. Okay, then in this case, a lot of people use something we call it packet marking to be able to use the two links at the same time. But that's something outside of the scope of this course, and I'm not going to discuss it in this course. Okay, but the most important that you can see both routes inside the routing table, and that's what is important. Okay, this is what I wanted to explain to you in this lecture. Let's stop now here and let's go directly and start doing the lab about the cost and the load balancing on OSPF.